Tonight, if you are listening to this when the room has grown quiet, when the sounds of the day have withdrawn, and the world is reduced to the dim glow of a screen or the gentle darkness behind half-closed eyes, try to imagine one thing. Imagine that Earth is not a stable place, not a planet that is always just right. For most of its history, this world has been a sequence of relentless trials. Colder, drier, then hotter again. Sea levels rose, sea levels fell, forests vanished, grasslands opened, and then closed again. In that context, there once existed countless species stronger than humans, faster, larger, with sharper teeth, with bodies seemingly designed better for specific environments. But many of those species disappeared. Humans did not. And the strange thing is this: humans did not win because of perfect bodies. We are not the fastest runners, not the best climbers. We have no claws, no thick protective skin, and most importantly, we do not evolve quickly. The human body changes very slowly, one generation after another, with differences so small that only after tens of thousands of years do they become clearly visible. So why is it that in a world that changes faster than genes, ever could humans still survive? The answer is not found in bones, not in muscles, not in the DNA of any single individual. It lies somewhere else, in a quieter capacity, less visible, but far faster than biological evolution: the ability to adapt. In this video, we will not tell the story of a great mutation. We will not speak of a miraculous moment when genes suddenly changed. Instead, we will follow a slower, deeper journey. A journey of small decisions, of habits passed down, of skills learned from others, of the ways humans change their environment instead of waiting for their bodies to change in time. And as you listen to this story, you may begin to realize something. Humans do not exist because we evolved the fastest. We exist because we learned to adapt before it was too late. Let this story drift slowly. Simply listen, and allow the history of our own species to gently carry you into sleep. If we look back at the history of life as a race stretching across billions of years, humans were never the front runners. We are not the fastest species, not the strongest, and not the species whose body is perfectly adapted to any single environment. On the contrary, if humans were placed on the same starting line as many other species in countless situations, we would lose from the very beginning. Imagine a vast savanna spreading beneath an unshielded sky. No shade, no shelter, only wind grass and open space stretching all the way to the horizon. There, an antelope does not need to think. It runs. And it is faster than any human who has ever lived. A lion does not need a long-term plan, just a sudden burst of speed, a few short seconds. The hunt is over before a human can even understand what is happening. An elephant does not need to avoid the heat. Its massive body can endure long days of drought long distances without water conditions that the fragile human body could hardly survive. And even smaller creatures, mice insects, beings almost invisible in the vast savanna, possess an advantage humans do not. They reproduce quickly, very quickly. A mistake does not mean the end. A failed generation can be replaced in just weeks or months. Their genes experiment, continuously adapt, relentlessly, and recover from catastrophe at a speed humans can never match. Place humans in the middle of that picture without weapons, without tools, without accumulated knowledge, and we do not stand out. We are slower, weaker, more vulnerable. If life were decided only by the speed of biological evolution, by who runs faster, who is stronger, who reproduces more, who changes genes more quickly, then humans, by every logic of nature, should not have survived for very long. Evolution, in its purely biological sense, is a slow process. It operates through extremely small changes in genetic material, filtered across many generations. A beneficial trait only truly matters if the individual carrying it survives long enough to reproduce, and if that trait is passed on to the next generation in an environment that continues to favor it. It is a process that requires time, relative stability, and a long chain of rare, favorable conditions. Humans, ironically, are a species with few advantages in this game. We live long lives. We reproduce slowly. A child needs many years before it can survive independently. A generation needs decades before it steps aside for the next. This means that every biological change in humans must wait a very long time before it can be tested in reality. If a trait proves unsuitable, the cost is not just one individual, but an entire stretch of time that has already passed. There is no way back, no undo button. Therefore, if relying only on random mutation and natural selection, humans cannot update their bodies quickly enough. Not fast enough to keep up with major shifts, not fast enough to correct mistakes when the environment changes direction, not fast enough to respond to shocks that arrive one after another. And more troubling still, Earth has never waited for anyone. Over the past few 100,000 years, a very short span compared to geological history, yet one that encompasses nearly the entire history of our species, this planet has constantly altered its own rhythm. Ice ages arrived, then retreated. Massive ice sheets advanced from the poles, forcing life to contract into rare refuges. Then, just tens of thousands of years later, the ice-melted waters rose, and familiar coastlines vanished beneath the sea. Global temperatures never stood still. They rose. They fell. There were periods of cold so prolonged that a single failed hunting season could collapse an entire community. And there were periods of warming so rapid that ecosystems stable for thousands of years were forced to reorganize. Sea levels fluctuated continuously, rising, falling, at times differing by more than 100 meters, enough to turn plains into seabeds and seabeds into new continents. Forests turned into grasslands. Grasslands closed back into forests. Familiar migration routes were cut off. Traditional food sources disappeared. Regions once abundant became barren, while areas once barren only briefly revived before changing yet again. For a species that evolves slowly, a world like this is not a playground. It is a continuous test, a series of questions that never allows a late answer. In such a context, waiting for the body to adapt in time is not merely a risky strategy. It is almost a pre-written sentence. In such a world, a survival strategy based entirely on waiting for genes to change is a strategy of self-destruction. An animal species may adapt extremely well to a stable environment, like polar bears to ice or camels to deserts, but that very specialization becomes a weakness when the environment changes rapidly. A biological trait optimized for today can become a burden tomorrow. The history of extinction is filled with species that once dominated an era only to disappear when living conditions exceeded the limits their bodies could tolerate. Humans are no exception to this rule. Our bodies are not designed to endure extreme cold nor extreme heat. We lack thick fur, we cannot hibernate, we cannot synthesize vitamin C on our own, and we do not possess the flexible digestive systems of many other omnivores. Biologically speaking, humans are a species with many limitations. So what happened? The difference does not lie in humans winning the race of biological evolution. In reality, we avoided that race altogether. Instead of trying to change our bodies to fit the environment, humans began doing something else. Something quieter, but far more decisive. They changed how they lived within that environment. When it was cold, they did not stand still, waiting for their bodies to grow more fur. They sheltered themselves. They wrapped animal skins around their bodies. They sought caves. They kept fire through the night. When food became hard, tough, or difficult to digest, they did not wait for thicker teeth or a self-adjusting digestive system. They crushed it. They cooked it. They shared it. They learned how to turn what was hard to eat into something that could sustain an entire community. When the environment became dangerous, they did not rely on claws or sharp fangs. They stood closer together. They observed. They warned one another. They coordinated assigned roles and acted together. These changes did not require thousands of generations. They occurred within the lives of real individuals. One harsh winter was enough to learn better sheltering. One failed hunt was enough to change the next strategy. One new threat was enough to force an entire group to adjust how it moved and kept watch. More importantly, those experiences did not disappear when individuals died. They were told again, imitated, remembered in action, in habit, in the way communities functioned. No genetic change was required, yet behavior changed. These choices left no clear marks in bones. They did not imprint themselves on skull shape or limb length. They did not immediately carve themselves into DNA, but they created another layer of adaptation. A layer faster than biological evolution, more flexible than genetic mutation, and less dependent on luck. It was a form of adaptation that did not wait for nature to choose. It allowed humans to respond proactively to change rather than passively endure it. Behavioral adaptation does not immediately make the body stronger, but it makes the way of living stronger. And that way of living continuously adjusted, transmitted not through genes, but through shared memory, became a temporary bridge that carried humans across periods when biological evolution could never respond in time. This was the moment humans began to exist, not only as organisms in nature, but as a species capable of adapting before it was too late. Unlike biological evolution, behavioral adaptation does not need many generations. An individual can learn a new skill within a lifetime. A group can change its survival strategy within a few seasons. A community can accumulate experience and pass it on to the next generation without any genetic change. This creates a fascinating paradox. Humans are a species that evolves slowly biologically, yet we are the fastest adapting species Earth has ever known. We do not change our bodies quickly enough, but we change our methods. That speed does not come from stronger muscles or sharper senses. It comes from a quieter capacity, but one with far greater reach, the ability to learn. A human does not need to personally test every mistake. They can observe. They can imitate. They can absorb experiences that others have already paid for. All it takes is watching, remembering, and repeating, but individual learning is only the first step. What truly creates an unprecedented speed of adaptation is social learning. Humans do not keep knowledge to themselves. They share it. They tell it. They demonstrate it through action so others can see. A small invention, a better way to bind stone to a wooden handle, a less labor-intensive method of making fire, a rule for dividing food that helps a group survive. A season of scarcity can spread through a community faster than any genetic mutation ever could. No need to wait for the next generation. No need to wait for reproduction. No need to wait for natural selection to filter outcomes over years. It only takes one person succeeding, then someone else sees it. And when a solution proves effective, it does not disappear with its inventor. It is retained, repeated, refined. Those who come later do not start from zero. They start where those before them stopped. Each generation inherits not only life, but a way of living. Over time, these small improvements stack upon one another, not in the exponential math of genes, but in layers of experience. A tool becomes better, a technique more efficient, a custom more suited to a changing environment. And most importantly, all of this exists outside the body. It does not need to be encoded in DNA. It lives in collective memory, in habit, in the rhythms of community life. That is why when the environment changes, humans do not wait for biology to respond. They adjust behavior first. They experiment culturally first. And only much later, if conditions remain stable long enough, does biological evolution begin to catch up. That is why, in a world of constant change, humans did not win through strength or speed, but through the ability to accumulate and transmit solutions faster than any other species. And from here, a larger question begins to take shape. If human adaptation occurs primarily outside the body in behavior and culture, then when did the boundary between biology and history begin to blur? That is what we will continue to explore as the story goes deeper. Over time, these layers of behavior skill and knowledge stack together, forming a kind of external memory for the human species. Not stored in genes, but in culture. This is precisely why, when we look back at human history, we see a recurring pattern. Whenever the environment changes too fast for biological evolution to respond, humans do not vanish en masse like many other species. Instead, they restructure the way they live. They move, they change diets, they modify tools, they reorganize social relationships. The race humans are running is not a race to see who has better genes. It is a race to see who learns faster, who shares better, and who adapts more flexibly to what has never happened before. What is important to understand is that this was not a consciously intelligent strategy from the beginning. Humans did not sit down and decide we will use culture instead of evolution. What happened was the result of countless small experiments, most of which failed. Groups that did not adapt in time disappeared. Groups that happened to develop more flexible ways of living survived longer, leaving traces in history. Over time, that flexibility became a core trait of the human species, not as a single gene, but as a behavioral pattern, a way of existing. And it is here that the central question of this video begins to come into focus. If humans did not succeed because of rapid biological evolution, but because of behavioral and cultural adaptation, what does that say about who we are? And more importantly, in a modern world where the environment is once again changing at an unprecedented speed, does that old strategy still work? To answer that question, we need to go deeper. We need to understand why biological evolution has limits that cannot be crossed, and why within those very limits, humans found another path forward. That will be the story of the next chapter. To understand why humans cannot rely on biological evolution to respond quickly to change, we first need to see evolution for what it truly is. Evolution is not an active force. It has no goal. It does not look toward the future. It is simply the accumulated result of small differences kept or removed over time. Evolution happens only when three conditions exist at the same time. First, there must be variation among individuals, not the fleeting surface-level differences we notice at a glance, but differences embedded deep within biological structure, tiny variations in the body, in physiology, in the way internal systems function. Second, those differences must be heritable. An individual can be stronger, smarter, or better adapted through learning. But if that advantage cannot be passed to the next generation by biological means, evolution does not record it. DNA does not store experience, it stores structure. And third, the environment must favor some differences over others, not by intention, not by morality, but by the blunt outcome: who survives, who reproduces more, who leaves a longer trace in the population. Only when all three conditions align does natural selection have material to work with. No one condition can replace the others. Remove a single link and the entire process stops. The problem is this: all three conditions require time, a great deal of time. Variation does not appear because it is needed. It appears randomly scattered and often at the wrong moment. Inheritance does not happen within one lifetime. It requires reproduction. It requires the next generation. And then that next generation must live long enough to keep the chain going. And the environment to truly select must hold a direction long enough. Not just change, but change in a stable, consistent way so that what is beneficial today is still beneficial tomorrow. Natural selection does not respond to short-term upheaval. A brutal winter can kill vast numbers of individuals, but if the seasons that follow return to normal evolution, may record nothing at all. Death happens, but it leaves no lasting genetic mark. Evolution learns only when the lesson repeats, when the pressure lasts long enough to imprint itself on the structure of the population. And that is the paradox. The environment often changes quickly, but evolution responds only to slow change. Between those two rhythms, a gap opens. A gap humans are forced to fill with another way of surviving. A genetic mutation does not appear because the environment needs it. Nature does not plan. There is no mechanism that looks ahead and decides what should change. Mutations arise randomly. They occur when DNA is copied, when small errors happen in that process, at the wrong time, in the wrong place, and most of the time for the wrong need. Most mutations bring no clear benefit. Many are harmless, but also useless. They exist quietly, making no difference large enough for selection to notice. Some mutations are harmful, reducing survival, increasing disease risk, or making reproduction more difficult. And only very rarely does a mutation happen to provide an advantage. Even in those rare cases, the advantage is never absolute. It matters only within a very specific context, a particular environment, a particular moment, and often a fragile set of conditions. But the appearance of a beneficial mutation has never been enough to create evolution on its own. The individual carrying that mutation must survive through a long chain of risks unrelated to the mutation itself. Accidents, illness, lack of food, conflict, pure chance. Then that individual must reproduce, not just once, but enough that the trait does not vanish immediately in the next generation. And then the next generation, those who carry the same mutation, must face the same chain of trials, and they must encounter an environment in which the mutation's advantage still matters. If even one link breaks, if the environment shifts, if the pressure disappears, if the advantage is no longer relevant, the entire process can stop before evolution has time to record anything. That is why, in so many cases, a beneficial mutation never spreads through a population. It appears, and then it disappears, leaving no trace. Evolution, therefore, does not respond to immediate change. One harsh season is not enough. A single disaster is not enough. A short-lived advantage is not enough. Evolution responds only when a trend lasts long enough, when pressure repeats across many generations, and when the environment keeps the same rules of the game for long enough that selection can do its work. In a rapidly changing world, that condition rarely exists. This can work well in a slow world, a world where climate stays stable for hundreds of thousands of years, a world where the environment remains unchanged long enough for biological traits to be tested across many generations. But Earth, especially during the era in which humans emerged, was not that kind of world. In that context, biological evolution is like a gear turning very slowly, while the environment around it keeps accelerating and changing direction. Not because evolution is inefficient, but because it is built for a different timescale. Another limit of evolution lies within the biological structure of humans themselves. We are a long-lived species. An individual can exist for decades, sometimes more. At the level of the individual, that is clearly an advantage. It allows learning. It allows the accumulation of experience. It allows complex social relationships to form. But in biological evolution, a long lifespan is a double-edged sword. Every extended generation means every trial run of nature is stretched out over time. Mutations cannot be tested quickly. Selection cannot filter rapidly. Mistakes, when they happen, take a very long time to be replaced. In humans, from birth to reproductive age is a long period of time. And from reproduction to the point when the next generation can continue, the chain is another long period. This makes the rhythm of human biological evolution slow in a way that cannot be avoided. Compared to fast reproducing species, the difference is enormous. In insects, one generation can pass in weeks. In bacteria, in hours. A new trait, if beneficial, can spread almost immediately. If harmful, it can be eliminated quickly without long-lasting consequences. In humans, a new trait can take decades just to begin being tested. And if it proves unsuitable, the cost is immense, not only to the individual carrying the mutation, but to a portion of the population's future. That is why, on the scale of purely biological evolution, humans are almost standing still compared to species with short life cycles. Not because we are poorly adapted, but because our biology does not allow rapid response through inheritance. In a stable world, that might not be a problem. But in a world that is always changing, it becomes a serious limitation. Human biological evolution is not designed for speed. It is designed for endurance. And it is precisely here that the difference between survival and disappearance no longer lies in the body, but in the ability to find another path to adapt in time. In bacteria, a mutation can be tested within hours. In insects, within weeks. But in humans, each trial takes decades. And if the outcome is unfavorable, the cost is enormous. On top of that, biological evolution does not allow rewinding. A trait that has been selected cannot easily be removed when the environment changes. A body optimized for one specific condition often carries hidden trade-offs. What helps survival today can become a burden tomorrow, but evolution cannot predict that. It only reacts after consequences have already occurred. That is why many species evolved very successfully in one era, then vanished when conditions changed. Not because they were weak, but because they were too perfectly fitted to a world that no longer existed. Humans, if relying only on biology, would not be exempt from that rule. Another important point often misunderstood is this: evolution does not work on individuals. It works on populations. An individual can learn quickly and adapt extremely well, but what that individual learns disappears when they die unless it is passed on by another route. Biology does not remember lived experience. DNA does not store lessons. That creates a large gap between the speed of individual learning and the speed of species-level change. Humans can learn in days, months, years. But biological evolution needs many generations to learn the same thing. That gap becomes increasingly dangerous when the environment changes quickly. There is a common misconception that if selection pressure is strong enough, evolution can happen very fast. This is only true under very specific conditions. Strong selection pressure usually comes with high mortality. In other words, for evolution to be fast, many individuals must die. That is not a sustainable strategy for a species that lives in communities, invests heavily in offspring, and depends on social cooperation the way humans do. A human population cannot accept losing most of its members just to test a new biological trait. The social, cultural, and survival costs are far too great. So even when environmental pressure rises, humans cannot accelerate biological evolution the way some other species can. Evolution is also limited by history. A body cannot be redesigned from scratch. It can only modify what already exists. Every new trait must be built on an old foundation. This closes off many evolutionary paths permanently. What is not already present is unlikely to appear no matter how much the environment might need it. The human body, therefore, is a collection of historical compromises. The spine supports upright walking, but aches easily. A large brain enables complex thought, but consumes enormous energy. Hands are flexible, but not powerful. These trade-offs cannot be resolved quickly through biological evolution, because every change triggers cascading consequences. Meanwhile, the environment does not care about those limits. It does not slow down to let evolution catch up. It changes according to climate, geological, and ecological cycles beyond the control of any species. At the intersection of a fast-changing world and a slow-changing biological mechanism, humans faced an implicit choice: accept the risk of extinction like so many species before us, or find another way to survive. That other path did not deny biological evolution. It simply did not place all hope in it. Instead of waiting for genes to change, humans began doing something far bolder. They created layers of adaptation outside the body. These layers are not tightly bound to bone muscle or the nervous system. They do not have to be born with the body. They can be learned, shared, modified throughout life. A child does not need to be born knowing how to make fire. They learn. A person does not need a special biological structure to hunt in groups. They observe and coordinate. A community does not need new genes to handle colder climates. They change how they live, how they eat, and how they move. These layers of adaptation are not limited by generations. They do not need reproduction to persist. An idea can spread in days. A new technique can be applied in the next season. A mistake can be eliminated before it causes long-term damage. Unlike biology, these layers allow rapid experimentation, rapid trial and error, and rapid retreat when necessary. A way of living that no longer fits can be abandoned without paying the price in mass death. A dangerous custom can be adjusted before it becomes a catastrophe. This does not make biological evolution disappear. Genes still exist. The body still faces biological limits, and genetic changes, when they occur, can still reinforce what behavior has already tested. But the role of biology has shifted. Biology is no longer the first line of defense against environmental upheaval. It no longer must bear the responsibility of reacting instantly to every change. Instead, biology becomes the stable foundation underneath a durable framework, flexible enough to carry culture, yet stable enough not to collapse whenever the environment changes direction. Above that foundation, behavior and culture take on the flexible role. They bend before change instead of resisting it. They experiment first before biology is forced to follow. And when a way of living proves effective for long enough in a stable enough environment, biological evolution finally has the chance to follow slowly behind and frame part of that result into the body. This is the reverse of how many people imagine it. It is not biology that leads culture. Very often, culture leads and biology quietly follows when time allows. And it is this layering a stable biological foundation with a flexible behavioral layer above that has allowed humans to survive in a world that never stands still. Understanding the limits of biological evolution does not diminish its value. On the contrary, it helps us see why humans are not slow by accident. We are slow where we cannot be fast, and fast where we can be flexible. And it is in the gap between these two speeds, the speed of genes and the speed of behavior, that a new kind of adaptation began to form. An adaptation that does not have to wait for the next generation, does not require mass sacrifice, and does not demand the body become something it was never designed to be. That is what will lead us into the next story, the story of human flexibility, and why within the biological limits that seem like disadvantages, we found our greatest advantage. There is a trait that is not easy to see when you look at humans from the outside. It is not found in height, not in strength, not in body shape. That trait lies in the way humans change without needing to change. In biology, flexibility is not a loud kind of power. It is the ability to adjust, the ability to respond, the ability to turn the same body into many different ways of existing depending on circumstance. And in humans, that flexibility reaches a level rarely seen. A human body can live in frozen regions where wind cuts into the skin, where the ground stays locked in ice for months at a time, where life draws inward to conserve every unit of energy. That same body can live in deserts where daytime heat scorches, where nights turn bitterly cold, where water is so rare that every drop carries survival value. That same body can survive on high plateaus with thin oxygen, where the air is so sparse that each breath becomes an effort. It can live in humid rainforests where bacteria, insects, and relentless moisture surround you. And it can live on small islands in the middle of the ocean where resources are limited, where people must learn to use everything around them. In each of those places, no different human body is created. There is no separate set of genes for ice, no separate set of genes for deserts, no separate set of genes for high plateaus or islands. What changes is not the basic biological structure. The skeleton is the same. The muscles are the same. The brain is the same. What changes is how the body is used, how humans allocate energy, how they organize time between activity and rest, how they interact with the environment, and more importantly, how they learn from what happened before. Human flexibility begins very early, right in personal life, from the first moment a child enters this world. A child is not born already carrying all the skills needed to survive. It does not know how to walk. It does not know how to speak. It does not know how to distinguish what is safe from what is dangerous, but it learns. It learns how to control its body. It learns to stand steady. It learns to balance. It learns to use its hands, not only to cling, but to manipulate, to test, to explore. It learns to speak not only to make sounds, but to connect, to ask, to warn, to share. It learns to read the world around it. It learns to recognize expressions on other people's faces. It learns to sense changes in tone. It learns to understand the unspoken signals a community uses to function. It learns to distinguish danger not through a complete pre-installed instinct, but through experience, through observation, through seeing the consequences of certain actions. These things are not written in detailed form inside DNA. There is no gene that specifically describes how to tie a piece of animal hide, how to avoid a dangerous animal, or how to behave inside a complex social group. Instead, DNA provides only an open capacity, a brain flexible enough to learn a nervous system, sensitive enough to respond, a body pliable enough to adjust. Everything else is activated and shaped by the environment. That is why two children born with extremely similar biological potential can become two people with completely different ways of living, simply because they grow up in different contexts. One child learns to endure cold. One child learns to avoid heat. One child learns to live among dense communities. One child learns to manage alone in sparsely populated spaces. Not because their genes are different, but because the environment has shaped how biological potential is used. This is the foundation of human flexibility, an adaptive ability not locked rigidly into biology, but expanded through learning, through experience, and through bonds with the people around us. The same biological potential yet results can differ dramatically. A child raised in a cold climate learns to keep warm, conserve energy, and prepare for winter. A child raised in a hot climate learns to avoid the sun, find water, and adjust daily rhythms. The body does not change its genes, but the way the body operates changes noticeably. This is a form of flexibility that biology allows the body responds within its range, adjusting how its systems function to match surrounding conditions. Heart rate, metabolism, reflexes, even the way the brain processes information can adapt to the living environment. But human flexibility does not stop at physiology. It expands into behavior, and from behavior it spreads into culture. Behavior is where flexibility becomes most visible. A person can change habits in a short time. They can abandon an old method and try a new one. They can observe consequences, adjust, and try again. This process does not require waiting for the next generation. It happens inside the life of the individual. What matters is this behavior can be copied. When one person discovers an effective method, others can learn it without facing the same level of risk. They do not need to repeat trial and error from the beginning. They do not need to pay the same price. Individual flexibility, because of that, becomes the flexibility of the group. And when behavior is widely shared, it begins to stabilize into habit. When habit is sustained over time, it becomes custom. When custom is passed across generations, it becomes culture. At each step of that transition, the speed of adaptation increases and the biological cost decreases. A community does not need to change genes to adapt to cold climates. They can change how they build homes. They do not need to change digestion to handle hard-to-digest foods. They can change how they prepare food. They do not need to change body structure to increase defense. They can change how they organize society. Human flexibility, therefore, is not random looseness. It is a multi-layered system. Biology creates a wide enough framework. Behavior fills that framework with fast responses. Culture preserves effective responses so they can be used again when needed. This creates a profound advantage in an unstable world. When environments shift quickly, species that depend heavily on biological specialization often face great risk. A body optimized too perfectly for one specific condition struggles to change direction. By contrast, humans are rarely the most optimized species for any single environment. But that very lack of optimization opens space for adjustment. Humans are not the fastest on the savanna, but we can learn to hunt in groups. We are not the best at enduring cold, but we can learn to keep fire. We are not the best at enduring hunger, but we can learn to store and share. Each time, flexibility replaces biological specialization. Another key element of flexibility is the ability to separate solutions from the body. When a species evolves biologically to solve a problem, the solution is tightly bound to the body. It cannot be removed, replaced, or quickly adjusted. But when humans solve problems through behavior and tools, the solution exists outside the body. A tool can be discarded, a technique can be improved, a custom can be replaced. And most importantly, these changes do not need to wait for the next generation to arrive. This flexibility also allows humans to live with contradictions that biology struggles to accept. An individual can learn to suppress reflexes, delay gratification, follow abstract rules. These things may not bring immediate biological benefit, but they can bring long-term benefit to the group. Here, flexibility is not only a response to the natural environment, it is a response to the social environment. Humans learn to live within complex structures. They learn to adjust behavior according to norms. They learn to sacrifice short-term benefit to maintain long-term stability. These capacities cannot be rigidly programmed into genes because society changes faster and more diversely than any natural environment ever could. Flexibility, therefore, becomes a condition for survival. But flexibility also has limits. It consumes energy. It requires learning. It demands time and mistakes. And not every individual or every community uses it equally well. Groups that fail to adjust in time can still disappear even if they share the same biological potential. What distinguishes humans is not that everyone adapts well. Throughout history, there have always been individuals who failed. Groups that could not adjust in time. Communities that vanished from the timeline. But humans do not operate as a single individual. We operate as a system. When one group of people happens to discover a more effective way of living, a hunting method, better suited to local conditions, a more stable form of community organization, a stronger strategy for a surviving harsh climate, that solution is not imprisoned within the boundaries of that group. It can spread through migration, through contact, through observation and imitation. A community does not need to discover everything from the beginning. They can receive what has already been tested elsewhere. They can learn from another group's success without paying the same cost. And in the opposite direction, when a solution fails, when a way of living stops fitting, the consequences are often local. One group can collapse without bringing down the entire species. One strategy can be discarded without erasing all accumulated knowledge. This creates a rare survival advantage. Flexibility allows risk to be distributed. Not every community gambles on the same way of living. Not every group depends on the same resources. Not every solution is adopted everywhere at once. Instead, humans experiment in parallel. Here, one method is tested. Elsewhere, another method is maintained. Some fail. Some succeed. Successes are kept. Failures are abandoned. This process does not require centralized coordination. No master plan. It happens naturally through the diversity of behavior and culture. That is why the failure of one group does not mean the failure of humanity. Human history is filled with vanished communities, but rarely has the entire species been pushed to the edge of extinction. Each time, system-level flexibility reveals its power. One group falls, another continues, not because they are biologically stronger, but because they carry ways of living that have already been tested elsewhere. Over time, this trait reshaped the course of human evolution. Biological evolution did not disappear. Genes still change. Beneficial traits can still be reinforced when the environment is stable enough and pressure lasts long enough. But biological evolution is no longer the primary driving force that decides the direction of the species. It becomes the foundation, a slow, stable structure, providing the basic capacity to learn and adapt. Above that foundation, behavioral and cultural flexibility takes on the guiding role. It determines where humans go, how we live, how we respond to change. And in a world that is always shifting, this layering slow biology and fast culture has allowed humans not only to survive, but to expand, to adapt, and to keep writing our story along paths that biological evolution alone could never open. And in the modern world, that flexibility has not vanished. It has only changed shape. Today, humans no longer face ice ages or predators the way our distant ancestors did. But the speed of environmental change, social, economic, technological, is even faster than before. What changes now is not temperature or rainfall, but the rhythm of life. How humans work, how we communicate, how we organize communities and make decisions. And once again, genes cannot keep up. The human body today is not fundamentally different from the bodies of people who lived tens of thousands of years ago. The brain, the nervous system, biological reflexes all still operate within the same ancient biological framework, but the way humans use those structures has changed completely. Technology is a new layer of adaptation. It does not change the hand, but it extends what the hand can do. It does not change the brain, but it expands the reach of memory, the speed of processing information, and the capacity to connect. Social organization is another layer of adaptation. Rules, institutions, norms, all are behavioral solutions designed to handle problems biology cannot solve directly. Systems of knowledge are an even deeper layer of adaptation. They allow humans to store experience beyond the limits of personal memory. They allow one generation not to begin again from zero. They allow mistakes to be recorded so they are not repeated blindly. What matters is these modern layers of adaptation still follow the same old principle. They can be created quickly, they can be replaced quickly, and they can be continuously adjusted as conditions change. When a technology no longer fits, it is left behind. When a social model creates instability, it is revised. When a knowledge system becomes outdated, it is updated or removed. All of that can happen within a single lifetime, sometimes within years, months, even weeks. No need to wait for reproduction. No need to wait for a new generation. No need to wait for natural selection. And just as in the distant past, this flexibility does not guarantee that every individual adapts well. It does not prevent crisis. It does not eliminate risk completely. It does not promise a painless path, but it allows humanity to adjust direction before it is too late. When the environment changes faster than genes, humans do not try to force the body to keep up. We change the way we live first. That is not a sign of absolute superiority. It is the sign of a survival strategy formed under hundreds of thousands of years of pressure. And that strategy, flexibility in behavior, flexibility in organization, and the ability to learn without stopping, is still quietly shaping how humans face the modern world today. Human flexibility is not a gift. It is a survival strategy forged under pressure, a strategy that allows existence in a world that never stands still. And from that foundation, something new begins to appear, not only the flexibility of individuals, but the accumulation of entire communities. That is the moment when learning stops being a solitary act and becomes a continuous current across generations. And that will be the story of the next chapter. There is a power that has been with humans since very early on, yet it is rarely seen with the naked eye. It makes no loud sound. It leaves no clear trace in fossils. It does not carve itself into bone or teeth. And yet that power has decided who survived, who disappeared, and who kept going farther in the history of our species. That power is the ability to learn. At first glance, learning seems so obvious that we rarely stop to question it. Humans learn because we have big brains, because we are curious, because we observe the world around us and respond to what happens. A child touches fire and pulls a hand back. A person trips and learns to step more carefully. A community goes through famine and finds a way to store food for the next season. At this level, learning seems like nothing more than an intelligent reflex, a personal ability that helps each person adjust in order to survive a little better. But if you look deeper, what makes learning an invisible power is not how fast an individual can learn. It lies here. Human learning does not stop at the individual. What one person learns is not locked inside the limits of a single lifetime. It does not vanish when memory fades or when that body no longer exists. It is passed on. One person retells what they have seen. Another imitates a more effective way of doing things. A community remembers what once happened, so it will not repeat the mistake. In that way, human learning crosses beyond biological limits. A large brain allows fast learning, but it is the flow of knowledge between individuals that creates real power. An individual can be intelligent, but an individual will grow old, will forget, will disappear. A community that learns together is different. It can keep experience even when the one who lived it is gone. It can accumulate understanding across generations without requiring genes to change. This is the point where learning stops being a personal skill. It becomes a collective survival mechanism, a mechanism that allows humans not to start from zero every time the world changes. In nature, many species can learn. A bird can learn flight routes. An animal can learn to avoid predators. An individual can learn from its own mistakes. But when that individual dies, most of what it learned dies with it. Humans are different. What one person learns can be passed on, not through genes, without needing reproduction, without waiting for a new generation to be born before knowledge begins to matter. It moves through other pathways, through behavior, through speech, through observation, through imitation. One person does it, another watches, and that is enough for knowledge to begin moving. A skill does not have to be explained in complex language. It only needs to be seen long enough, one correct motion, one effective sequence of actions, one way of handling a situation that has already been tested. Learning in this sense does not need to be perfectly precise. It only needs to be right enough to provide an advantage. A child does not need to test every danger in order to know what to avoid. The child does not need to touch fire to understand that fire causes pain. The child watches adults' reactions, hears warnings, recognizes the seriousness in a voice, and just like that, a lesson is passed on without being paid for in injury. The child learns not only from words, but from context, from actions that accompany those words, from what is done again and again in everyday life. Over time, those lessons connect to one another. They form a picture of the world that the individual has never experienced in full. And in that way, each person is born not starting from zero. They begin on a foundation already built, a foundation made of what was tried and failed before, of dangers already recognized, of solutions already tested. None of us has to rediscover every rule of the world alone. We inherit them, and that inheritance changes the entire rhythm of human adaptation. Instead of each lifetime being a restart, humans enter the world with a storehouse of knowledge accumulated across generations, not stored in DNA, but carried in the shared memory of the community. That is why a child born anywhere can learn how to live there, not because the body is already ready, but because the path to survival has been mapped out in advance, and that foundation grows larger over time. Individual learning is the first step. One person tries a new method, observes the result, adjusts, tries again. But social learning is where real power appears. When one person finds an effective solution, others can adopt it without paying the same cost. They do not have to make the same mistake. They do not have to face the same risk. An efficient hunting technique can spread through an entire group. A better way to keep fire can be copied in just a few days. A suitable migration strategy can become a norm for many generations. The speed of that spread is far beyond any biological pathway of inheritance. No reproduction required, no new generation required, no waiting for natural selection, only observation and memory. But human learning is not only simple copying. We do not merely repeat, we adjust. A learned technique is never a fixed mold. It can be modified to fit new circumstances, different terrain, different climate, different resources. A hunting method that works on open plains can be adjusted when moved into dense rainforest. A way of keeping fire suited for a dry winter can be altered when facing a wet environment. No solution is copied perfectly forever. Each application is a new experiment. A solution once used can be improved with every use. A redundant step gets removed. A detail gets added. A sequence gets rearranged to save time and energy. These changes are often very small, sometimes nearly unnoticeable, but they do not disappear. One person adjusts, someone else learns the adjusted version, then another person refines it a little further. An imperfect idea is rarely thrown out immediately. It gets tried, repaired, used again, and it is the repeated use itself that reveals weaknesses and possibilities for improvement. Over time, those tiny changes accumulate, not inside the memory of a single person, not inside the skill of one individual, but inside the whole community. One person holds one part of the story, another holds the rest. No one owns the entire process, but the community does. This is the point where learning surpasses the limits of biology. Biology can only experiment through reproduction and selection. Each experiment is a lifetime. each mistake can cost death. Learning is different. It allows experimentation without mass sacrifice. It allows what is good to be kept and what is bad to be removed without waiting for the next generation. And because knowledge accumulates outside the body, it is not limited by personal memory or lifespan. In that way, a human community becomes a living archive, constantly updated, constantly revised, a storehouse of knowledge that biology alone could never create. Biology does not remember details. It only preserves structure. But learning can process how to do things, the sequence of actions, what should be done, and what must never be repeated. One generation does not only pass on life, it passes on a way of existing. When that process repeats across generations, something new appears. Knowledge begins to accumulate. No single person in a community holds all knowledge, but the community as a whole knows more than any individual. One person knows how to hunt. Another knows how to make tools. Another understands the weather. Another remembers migration routes. No one has to know everything. People only have to be connected. In that way, learning becomes a distributed power, not concentrated, not dependent on any single individual. If one person is lost, some knowledge may go with them, but not all of it. The rest remains stored in other people's behavior, in habits and customs. This is an enormous survival advantage, quiet but durable across time. In the natural world, many species gamble their survival on a few exceptional individuals, the strongest leader, the best hunter, the most reproductively successful animal. In systems like that, stability is fragile. If the central individual disappears through illness, accident, or environmental change, the entire structure can collapse. What was accumulated in that individual's life has nowhere to go. No one carries it forward. Humans avoid that trap in a very different way. We distribute knowledge. No one holds everything. No one is the single bottleneck. No one is the only place where survival experience is stored. Knowledge is broken into pieces and spread across the community. One person knows this. Another person knows that. And between them, a network of learning forms. When one individual is lost, a part of knowledge may be lost, but not all of it. What remains still exists, held in other people's behavior, in routines, in the way the community functions each day. That distribution makes the human system far harder to collapse than systems that rely on a single center. Social learning, therefore, is not only a way of transmitting knowledge, it is a protection mechanism, a mechanism that allows humans to endure loss without losing the entire ability to survive. Learning brings another advantage, even more subtle. It allows humans to adjust behavior before consequences unfold on a large scale. In nature, many lessons are learned only after damage has already occurred, an environment changes, a species fails to respond in time, and consequences spread before there is a chance to correct course. Humans, through social learning, can break that cycle. A community can observe another group's failure without having to suffer it directly. They hear about it, they remember it, they adjust before the mistake repeats. A disaster in a distant place is not only an isolated event, it becomes a warning. Stories are retold, signs are emphasized, new rules are formed based on someone else's experience. In that way, information does not need to be paid for through direct loss in order to become useful. Humans can prepare before danger comes close. We can change direction before an old path leads to a dead end. And in a world with no certain map of the future, the ability to learn from others' mistakes becomes one of the greatest survival advantages our species has ever had. Information does not need to be paid for in death to have value. Over time, this capacity to learn creates a kind of collective intelligence, not the intelligence of a single brain, but the intelligence of an entire system. A system that can run parallel experiments. One place tries one method, another place tries another. Results are compared. What works is kept. What fails is discarded. That entire process moves faster than biological evolution and is less brutal than natural selection. Learning, therefore, becomes the primary mechanism by which humans face uncertainty. When the environment is unstable, when the future cannot be predicted, The ability to learn from others becomes a greater advantage than any single biological trait. This also explains why humans are especially sensitive to the loss of knowledge. When a community is isolated too long, when the transmission of knowledge is interrupted, flexibility declines. Not because genes change, but because the learning system is broken. On the other hand, when knowledge is widely shared, when learning continues without interruption, humans can adapt at a speed far beyond any biological limit. In the modern world, the principle remains the same. Technology may change the form of learning, but it does not change its nature. The way knowledge is recorded can be different from stories told by the fire to symbols carved on stone, from symbols to writing, from writing to printed books, digital data, and global networks. But the core does not change. Knowledge still accumulates not in one single mind, but in many minds at the same time. Knowledge is still passed on from those who lived through something to those who never did, from one place to another, from one generation to the next. And knowledge is still improved by many different people. No one owns the final version. No one holds a monopoly on truth. Each person adds something small, an observation, an adjustment, a critique. Over time, those contributions stack up, forming systems of understanding far beyond the ability of any single individual. The only difference is speed. What once took centuries to spread can now move in seconds. Mistakes that once required generations to recognize can now be exposed almost instantly. But that speed did not come from nowhere. It was built on the same ancient foundation that existed long before modern technology: the ability to learn socially. Technology only amplifies what was already there. It does not create the instinct to learn together. It only expands the reach and tempo of that instinct. And just as in the past, learning is still not an absolute promise. Learning does not make humans immortal. It does not remove risk. It does not guarantee that every decision is right. Humans can still be wrong. We can still misunderstand. We can still follow paths that lead to serious consequences. But learning gives something else, something more important than perfection. It allows humans to correct course before it is too late. A decision that no longer fits can be reconsidered. A system that creates problems can be adjusted. A dangerous direction can be abandoned before consequences become irreversible. Learning allows us to change direction when conditions change, instead of clinging to old choices only because they once worked. And in a world with no fixed route, no permanent map, no guaranteed promise for the future, the ability to keep learning becomes a condition of existence. Not to avoid every mistake, but not to be trapped inside a single mistake. Not to control the world completely, but to keep adjusting as the world shifts. Because of that, humans do not need to know every answer in advance. We only need to keep the ability to learn together long enough, open enough, and flexible enough to keep surviving in a world that never stops moving. That is why throughout our history, humans did not need to become the strongest species. We only needed to become the species that learns the fastest and learns together. And from that invisible strength, something even deeper begins to form, a process in which learning does not only help us adapt, but begins to create new environments for humans themselves. There is an important moment in human history, not loud, not tied to a single invention, and yet it completely changed the way humans exist. It is the moment humans stopped only adapting to the environment and began to act back on the environment. For most of life's history, the environment set the rules of the game. Living things either adapted or disappeared. Forests opened or closed. The climate warmed or cooled. Water rose or receded. Life responded. Humans began the same way. We migrated when conditions shifted. We adjusted how we lived when resources vanished. We learned to survive within the limits that were given. But gradually something else appeared. Instead of only asking, how do we live in this environment? Humans began to ask, how do we make this environment easier to live in? This was not a fully conscious decision from the beginning. It was the result of countless small experiments, simple actions meant at first to solve immediate problems, but over the long run, they changed the very context humans had to face. A forest was burned, so hunting would be easier. Not to destroy, but to open the view so predators would have fewer places to hide, so humans could move, observe, and coordinate more effectively. Water was diverted closer to where people lived, not to reshape an entire river, but to shorten the daily distance of carrying water, to make life more durable through long, dry seasons. Land was cleared to plant crops, not to control nature completely, but to create a more stable food source than the uncertainty of hunting and gathering. A footpath was opened by repeated steps. At first, it was only a strip of grass pressed down. Then it became a familiar trail. Then it became a route connecting home water and hunting grounds. Each action taken on its own seems small. No single action is large enough to be called a revolution. But when repeated, when maintained year after year, generation after generation, they begin to accumulate. Burned areas change plant structure. Diverted water changes soil moisture. Familiar paths change how humans and animals move. Small changes stack on top of one another, and the environment once seen as an unchanging condition begins to shift under human footprints. The important point is this: humans did not need to change their genes to do it. They did not need a new body to transform the landscape. No extraordinary strength, no special biological trait. They only needed new behavior, a different choice, a different habit. They only needed new tools, stone-sharpened wood, carved fire, controlled. And they only needed new organization, division of labor group coordination, shared responsibility. In that way, humans created secondary environments no longer entirely natural, but not yet fully artificial either. They became spaces shaped by human choice, by behaviors repeated long enough to become features of the landscape. In those environments, humans were no longer passive creatures under natural conditions. They became part of the shaping force. And from that moment, the survival story of our species was no longer only a story about adapting to the world, but a story about restructuring the world in order to keep existing. A place once wild became a place to live. An ecosystem once diverse shifted into a different structure. A resource once scattered became concentrated and controlled. This was a profound turning point, because when the environment changes, the pressures of selection change as well. Humans no longer only responded to the environment. We began to create new pressures for ourselves. When humans learned to keep fire, night was no longer an empty space filled with threat. Darkness still existed, but it no longer meant total helplessness. Fire brought light, it brought warmth, and more than that, it brought a feeling of control in a world that was otherwise difficult to predict. Night was no longer only a time to shrink inward and wait for morning. It became part of live time, a quiet stretch to share food, to pass down stories, to strengthen bonds inside the group. When humans built shelter, cold winds and storms did not disappear, but they lost some of their absolute power. Weather no longer directly decided moment by moment who lived and who died. A simple roof was enough to create a boundary between a fragile body and a harsh world, not to challenge nature, but to slow its impact. When humans learned to store food, time itself began to change meaning. Life was no longer chained to each single day's hunting success. Lean seasons no longer meant immediate starvation. Food was kept, shared, distributed according to the community's needs. This did not erase anxiety, but it shifted anxiety from the present into the future, from instant reaction to longer calculation. This new environment did not eliminate risk completely. Disasters still happened. Harvests could still fail. Resources could still run out. But it reshaped the kind of risk humans had to face. Instead of random risks that could not be predicted, humans began to face risks linked to organization. Keeping fire required protection. Shelter required maintenance. Stored food required fair distribution. New dangers emerged: conflict within the group, mistakes, and allocation over dependence on a single source. And from there, which biological traits mattered most began to change. No longer only endurance against cold or heat. No longer only speed or strength. Other abilities slowly became more valuable: the ability to cooperate, the ability to remember, the ability to communicate, the ability to anticipate consequences. In the new environments, humans created survival no longer depended entirely on how much the body could endure, but on whether the individual could function well within the system. Who knew how to keep fire for the group? Who knew how to build and repair? Who knew when to share? Who knew how to warn when danger came close? Biology began to enter a new arena, not set by nature alone, but set by humans themselves. And from there, evolution no longer responded only to forests, ice, or deserts. It also responded to the social environment and the cultural environment humans wove around themselves. It was no longer simply the person who tolerated cold best who survived, but the person who knew how to stay warm best. Not the one who ran fastest, but the one who coordinated best. Not the one who was strongest, but the one who adapted best to the environment humans themselves had created. This formed a special feedback loop. Humans changed the environment. The new environment created new pressures. Those pressures over time could shape biology in return. But the key point is this: the loop begins with behavior, not with genes. When humans cleared land for farming, we did not only reshape the landscape, we reshaped diet daily rhythm, the organization of community life, the division of labor. Each change created new demands, new skills to learn new rules, to form new relationships to maintain. The human-made environment, therefore, never stands still. It is continually adjusted, continually repaired, continually expanded. And it is this flexibility that completely changed the trajectory of human adaptation. In nature, each species is often limited by the environment that produced it. A forest species adapted to shade moisture and dense vegetation does not easily survive in an arid desert where water is rare and temperatures swing harshly. A marine species born to move through water cannot step onto land without deep biological change. Those limits are carved into the body. They are the result of thousands, millions of years of natural selection in a specific context. Humans broke those limits, but not by the familiar biological route. We did not wait for our bodies to become better at heat before living in deserts. We did not wait for lungs to change before living high in thin air. We did not wait for thicker skin to withstand northern cold. Instead, humans carried their environment with them. They carried fire, a piece of the sun kept within reach. Fire let them create warmth where there was no warmth. Cook food where food was otherwise hard to digest. Stretch living time deep into the night. They carried tools, not to replace the body, but to extend it. A sharpened stone stood in for claws. A stick stood in for brute muscle. A trap stood in for speed. They carried knowledge. What was learned in one place could be applied elsewhere. Experience accumulated across generations was packaged into habits, techniques, and stories. And they carried social organization, how work was divided, how decisions were made, how people supported one another when crisis arrived. Wherever humans went, we did not only adapt to the surrounding space, we began to restructure it. We chose campsites based on wind and water. We changed terrain to make movement and life easier. We created fixed points homes, gathering places, storage sites inside a world that was always shifting. The principles carried along were not always identical, but they shared a common logic: reduce uncertainty, increase control, and create familiarity inside unfamiliar environments. In this way, the world gradually became a chain of semi-artificial environments. Each place had different climate, different terrain, different resources, and yet everywhere, you could still recognize the mark of the same strategy. Humans turned the places they arrived in into a version, even if only barely, of home that could be lived in. Not because the world became uniform, but because humans carried survival principles tested over time. And it was this ability, the ability to carry one's environment, that allowed humans to expand the range of existence far beyond traditional biological limits. to set foot in nearly every corner of the planet without needing to become a different species. This also explains why humans could spread across almost every region of Earth in a very short time by biological standards. Not because we were perfectly suited to every environment, but because we knew how to make environments fit us enough to survive. However, changing the environment did not always bring immediate benefit. Every intervention carries consequences. A burned forest can create short-term advantage, but alter ecosystems over the long term. Water control can stabilize daily life, but create new dependencies. Humans could not always foresee those consequences. But because of social learning, these outcomes were not merely experienced, they were remembered. One environmental mistake could become a lesson elsewhere. One local disaster could warn communities that had never lived through it. In that way, changing the environment was not only a physical act, it became a continuous learning process between humans and the world around them. Gradually, the boundary between adapting and creating conditions became blurred. Humans did not only live in environments, we lived in environments shaped by ourselves. And here a large question begins to appear. When humans change the environment to fit themselves, does biology remain still forever? Or over time, will those new environments begin to leave traces inside the human body itself? That is where the next story begins, where culture and biology no longer move in parallel, but begin to interweave. And that is what we will continue to explore in the next chapter. There are moments in human history when the boundary between biology and culture becomes so blurred that it is difficult to tell them apart. Not because genes disappear, not because culture replaces biology, but because the two begin to influence each other in a slow, steady, and enduring loop. One of the clearest examples of that process is not found in stone tools, not in fire, and not in agriculture. It is found in milk. For most mammals, milk is the food of early life, a temporary source of nutrition designed to support rapid growth in the first months. As the young animal grows, the ability to digest milk fades. The enzyme needed to break down lactose, the sugar in milk, gradually decreases in activity. And that makes perfect sense. In nature, there is no biological reason for an adult individual to continue consuming milk. Humans were no different at first. For most of our species' history, children drank breast milk. Adults did not. The decline in lactose digestion after weaning is the human body's default state. But then culture intervened. When humans began to domesticate animals, cattle, sheep, goats, the relationship between humans and food entered an entirely new stage. Milk was no longer only a food reserved for the young. It was no longer something that existed briefly and then disappeared with maturity. Milk became a stable source of nutrition, a source that could be harvested repeatedly, day after day, season after season. And more importantly, it could be taken without killing the animal. This was a major shift in how humans approached resources. Instead of hunting and ending a life cycle, humans learned to sustain it. They learned to raise animals to protect them and to draw from them over time. But the key point is this: at first, this was entirely a behavioral change. No new gene appeared to allow humans to drink milk. No mutation instantly reshaped digestion. Humans learned how to milk a skill that required patience and close observation. They learned how to store milk at first in crude ways, then more refined as experience accumulated. They learned how to use milk as part of the diet, not only to drink it directly, but to supplement energy during periods of scarcity. Yet while behavior changes quickly, the body does not. Biology does not respond instantly to a new habit. For many adults, drinking milk was not comfortable bloating, stomach pain, indigestion. Those reactions were not signs of failure. They were reminders that the body was still operating on an older design. Biology was still speaking clearly. This body was not built for that. And in many human populations, that remains true today. In many places around the world, lactose intolerance in adulthood is still the common state. The body does exactly what it was programmed to do. Long ago, it reduces milk-digesting enzyme production after weaning. What is remarkable is that humans did not stop. We did not abandon the new behavior just because the body had not fully adapted. Instead, we adjusted how milk was used. We changed quantities. We experimented with different methods to reduce discomfort. And in some communities, especially groups that depended heavily on herding, something else began to happen, not at the level of a single individual, but across many generations. In those communities, milk was not a minor option. It was a crucial source of survival, a frequent part of the daily diet. And that long-term dependence created a new context, an environment in which very small biological differences began to matter. Not everyone who could drink milk instantly became healthier. But those who suffered fewer negative effects gained a small advantage repeated over time, an advantage too subtle to notice in one lifetime, but steady enough to begin making a difference when viewed on a longer scale. And here, the relationship between culture and biology entered a new phase where behavior not only moved first, but quietly shaped the path that genes would later follow. Individuals who retained the ability to digest lactose as adults held a small but consistent advantage. They could use milk as extra energy and protein. They had more options during times of food shortage. That advantage was not dramatic. It did not decide life or death overnight, but repeated across generations, it began to accumulate. This is the core point. Genes did not change first so humans could drink milk. There was no biological need that made the body suddenly decide to digest lactose in adulthood. No signal from the environment told DNA, now you should change. What appeared first was not a gene, but a milk-drinking culture. Humans changed how they lived. They kept livestock. They milked regularly. They brought milk into the diet as a familiar energy source. That alone was enough to create a new environment. Not a wild, natural environment, but a daily living environment built by human practice. In that environment, people no longer had the same biological experience. Those who could digest lactose as adults did not need to be superior in every way. They only needed to be less disadvantaged, less pain, less discomfort, less need to avoid a readily available food. The advantage was small, almost invisible within a single human life. But evolution does not measure advantage by immediate sensation. It measures by repetition. A small advantage repeated in the same context across many generations can become significant. That is why biology does not lead. Biology does not go first to clear the road for new behavior. It does not predict the future. It does not prepare in advance for culture. Culture leads. Culture creates new habits. Culture keeps them long enough. Culture shapes a context in which certain genetic variants suddenly fit better, and biology slowly follows behind, not by inventing new genes from nothing, but by preserving variants that already existed, variants that previously had no special meaning. Over time, in communities that depended on herding, the proportion of adults able to digest lactose increased. Not because the entire human species suddenly adapted to milk in one unified direction, but because local selection pressures were created by a very specific cultural practice, drinking milk regularly. Elsewhere, where herding traditions did not exist, milk was not a crucial resource. The ability to digest lactose did not offer a clear advantage, and when a trait offers no advantage, evolution has no reason to amplify it. So, it does not spread widely. It remains low, a neutral variant not strongly selected. The result is a complex picture, and one that is deeply characteristic of humans, the same species, the same biological origin. And yet small biological differences are distributed unevenly across the world map. Not by accident, not by race, but as reflections of each region's cultural history. Where milk drinking persisted for a long time, bodies gradually adapted to it. Where milk drinking did not matter, bodies had no reason to change. Biology in this case does not tell a story of wild nature. It tells a story of human choices repeated long enough to leave a mark inside the body. This is not a story about milk. It is a story about interweaving. Culture does not only help humans adapt to the environment, it creates new environments to which biology must respond. When humans change how we eat, how we live, how we structure daily life, we also change the kind of pressure our bodies face. This change does not happen overnight. It does not happen in a single lifetime. It does not even appear clearly within one generation. It unfolds along a longer timeline, long enough for biology to respond slowly. And the important point is, this biology is not forced to change. The body does not know humans have chosen a new way of life. No gene actively adjusts to catch up with culture. Instead, in every generation, there are always small differences, chance genetic variants. Most of these differences make no obvious difference at all. But when the context of life changes, some of them suddenly fit better. Not because they are absolutely better, but because they are less disadvantageous in the new circumstances. Culture does not rewrite DNA. It does not redesign the human body. Culture does something far subtler. It selects from what already exists. When a cultural behavior is maintained long enough, repeated steadily enough, it creates a familiar environment. An environment in which some biological traits have more opportunity to express than others. Over time, those small differences do not vanish. They are retained, and gradually they leave traces inside the human body. Milk is simply a clear example because it is easy to observe. But the mechanism behind it is not limited to milk. It is the way culture quietly shapes biology, not by command, but by repetition. And the same logic applies elsewhere. Diet shapes metabolism. Daily rhythm shapes physiology. Social organization shapes reproductive behavior. All of these are pathways through which culture creates a context for biology to respond. This changes how we understand evolution. Evolution is no longer only a force coming from outside humans. It is no longer only a reaction to forest ice or desert. It becomes increasingly a response to the world humans create. A world of fire tools shelter new diets and complex social structures. In that world, traits that once mattered most can become secondary, and other traits linked to digestion, metabolism, or physiological response can gradually be reinforced. Not quickly, not everywhere at once, not according to any clear plan, but in the way evolution always works: slow, local, and dependent on context. The story of milk reveals something even deeper. Humans do not only adapt to nature, we adapt to ourselves, to choices made in the past, to ways of life that became familiar, to environments we created and then lived inside. Culture clears the path. Biology follows, not to keep up with every change, but to stabilize changes that prove durable. And within that interweaving between genes and behavior, between biology and culture, humans continue to evolve along a path unlike any other species. Not faster, not stronger, but more flexible. And that is the foundation for understanding the next chapter, when the question is no longer, how did humans adapt? But instead, how will humans continue to adapt in a world shaped by our own hands? There are places on Earth where simply standing still and breathing already feels like an effort, not because of cold, not because of heat, but because the air is thin. At elevations of several thousand meters above sea level, oxygen is still there, but significantly less of it. Each breath delivers less energy. Each step costs more. For most modern people, this is a clearly stressful physiological environment. Dizziness, fatigue, headaches, nausea. The body reacts as if it has been pushed out of a familiar safe zone. And if you look through the lens of classical evolution, a question immediately appears. Why do humans live long-term in places like this? In nature, high plateaus are always harsh environments for life. Thin air means each breath brings less oxygen. Low temperatures drain energy faster. Strong, constant winds carry warmth away. Sparse vegetation limits food. This is not a place designed for long-term stability. So in most ecosystems, high plateaus are only temporary spaces. Many animals go up there seasonally when conditions are more favorable, when food briefly becomes abundant, and then retreat to lower altitudes where their bodies function more efficiently. Few species can live there permanently. and almost no species builds a sustainable life under prolonged oxygen scarcity. Yet humans are an exception, a species without special lungs, without an obvious biological structure built for thin air, without a natural mechanism that makes high-altitude work efficient. And yet humans do not merely pass through plateaus. They settle, they build communities, and they live there stably for many millennia. Like many earlier stories in human history, the answer to this paradox does not lie entirely in biology. It begins with behavior. When humans first stepped onto high plateaus, they were not suited to that environment. Their bodies came under clear physiological strain. Work capacity dropped. Recovery took longer. Risks of illness and exhaustion increased. Every biological signal said this is not an easy place to live. But humans did not leave immediately. Instead of waiting for the body to change, they changed the way they lived. They adjusted daily rhythms. They moved more slowly to conserve energy. They shifted heavy labor to times that made more sense. They rested more to avoid collapse. They learned to listen to the body's limits, not to break through them, but to live within what the body allowed. These adjustments may seem small, but they were decisive. They did not require new genes. They did not require generations of waiting. They required learning observation and acceptance of a different pace from life at low altitude. And from those seemingly simple behavioral shifts, the first door opened, allowing humans to remain long enough for biology later to have a chance to catch up. They did not only adjust individual routines, they changed how the community was organized. Heavy work was no longer placed on one person. It was shared, redistributed according to health and capacity. When one person grew exhausted from low oxygen, another stepped in. When one body weakened, the community did not leave them behind. Life on the plateau then was no longer a trial of isolated individuals. It became a problem of coordination. Humans also carried with them everything they had learned before. Knowledge of fire, how to keep warm against unrelenting cold wind. Knowledge of shelter, how to build enclosed spaces to resist low temperatures and strong gusts. They brought survival principles proven elsewhere, sharing resources, supporting one another, and maintaining community stability in high-risk environments. At the early stage, human long-term presence on the plateau was not the result of a body matched to altitude. It was the result of cultural adaptation. The way of life was adjusted. Work patterns were changed. Community functioning was restructured to reduce pressure on each person. Biology at that point was only trying to keep up, not truly changing. But as in the story of milk, when a cultural behavior does not appear briefly, but is maintained long enough, something else begins to happen. Not immediately, not uniformly, and not for everyone. It is simply that in communities that have lived on high plateaus for many generations, very small biological differences, once almost unnoticeable, begin to matter. Some people tolerate low oxygen a little better, recover a little faster, feel fatigue a little less. Those differences are not large enough to create a clear divide within a single lifetime, but when repeated in the same harsh environment across many consecutive generations, they begin to accumulate, not because the body decides to change, but because the living environment sustained by cultural behavior creates a context in which those small differences suddenly become important. And from there, biology begins to enter the story slowly, quietly following choices humans made long before. Those who tolerate low oxygen better are not necessarily stronger. They are simply less disadvantaged. They tire less, recover faster, work more effectively in thin air. That advantage once again is small, not enough to be obvious within one generation, but enough to accumulate when repeated across many generations in the same environment. This leads to an important discovery in modern science. In some populations that have lived for a very long time on high plateaus, especially in Tibet, the human body does not respond to oxygen scarcity in the same way lowland bodies typically do. When someone from the plains goes up to a high plateau, their body often reacts sharply. heart rate rises quickly, breathing becomes rapid, the mind feels dizzy, work capacity drops dramatically. That is the familiar response of a body pushed beyond its comfortable physiological range. But in communities that have lived there for many generations, the response is not the same. They do not simply get used to it. This is not a temporary adjustment achieved after a few weeks or months. They are different slightly at a biological level. And that difference does not appear as something easy to see. Not obviously larger lungs, not a stronger heart in a simple sense, not superior muscles or endurance. It lies deeper. It lies in how the body regulates its response when oxygen becomes scarce, and how physiological systems are triggered or restrained in thin air. Instead of overreacting, pushing heart rate and respiration too high, creating heavy strain on the body, these bodies operate on a different rhythm, more stable, more economical, more efficient over time. And importantly, these differences do not appear everywhere. There are plateaus. Humans in the Andes, for example, show different kinds of adaptations. Their bodies respond to low oxygen through a biological pathway not the same as Tibet. Humans in the Ethiopian highlands show yet another pattern, not fully matching either of the two above. The same environmental challenge, low oxygen, high physiological stress risk of declining health, yet multiple biological routes have emerged. This reveals an important truth about human evolution. There is no single optimal design for living at high altitude. There is no universal answer applied to every community. No single biological model that everyone must converge toward. Instead, there are multiple solutions, each formed within a specific context with its own settlement history, its own way of life, and its own cultural choices. Which solution is retained depends not only on the natural environment, but on the path that community has traveled. The plateau, therefore, is not only a physiological challenge, it is one of the clearest places to see how culture clears a path and biology, not hurried, not uniform, chooses different routes to follow behind. But the story does not stop there. When scientists began to study more deeply the origins of these biological differences, they found a trace that was astonishing. Part of the ability to adapt to low oxygen in Tibetans is linked to very ancient genetic variants, so ancient they do not originate from modern Homo sapiens. In other words, the trace of another human species still exists inside our bodies. When those variants are traced further back, they are not products of recent changes in the history of our species. They come from Denisovans, an ancient human group that once lived in Asia, existing alongside and interbreeding genetically with our direct ancestors. This does not mean Denisovans lived on high plateaus in the way modern humans understand today. There is no evidence that they built stable high-altitude communities or developed a culture tightly bound to extreme elevation. The important point lies elsewhere. Those biological variants were formed in an ancient context, possibly under environmental pressures, quite different from modern plateaus, climate instability, harsh living conditions, or physiological challenges we can only infer indirectly. For a very long time, those variants existed quietly. They did not necessarily offer a clear advantage. They were not harmful enough to be removed. They simply remained. And then tens of thousands of years later, modern humans, through behavior, through cultural choice, placed themselves into a new environment, oxygen-poor, high plateaus. At that moment, those ancient variants suddenly mattered. Not because genes changed, not because the body learned something new, but because the context changed. A biological trait, once neutral or minor, now helped the body respond more gently to oxygen scarcity, reducing physiological strain, supporting long-term stability. Culture, in this way, does not create new genes. It awakens the value of what has existed for a very long time. The Denisovan story, therefore, is not a story about an ancient human species being more advanced. It is a story about time and the layering of history. Biological traces formed in a distant era can wait tens of thousands of years before finding the context where they become useful. And when that context appears not purely from nature, but from human choices about how to live, evolution does not have to start over. It only has to select again. This is one of the deepest lessons from high plateaus and oxygen. Human evolution is not only the story of what is newly created, but also the story of what has existed for a very long time, carried through time and merely waiting for the right moment to become necessary. Once again, biology does not go first. Those genes already existed. They did not appear because humans decided to live on high plateaus. But when human culture brought people into that environment and maintained their presence long enough, those ancient variants suddenly gained value. Culture opens the door. Biology steps in. This is a key point in how humans evolve. Not every biological change is the result of new mutations. Sometimes evolution is simply the creation of a new context in which what already exists can finally matter. The plateau, therefore, is not only a harsh environment. It is a natural laboratory where we can see the interweaving of settlement behavior, survival culture, deep genetic history, all operating within a single system. Humans did not conquer the plateau with the body. They entered it with behavior. Biology came only afterward, quietly, slowly carrying traces of the past that no one at the time could have recognized. And here a larger picture begins to appear. Humans do not evolve only in nature. We evolve inside our own history. Every decision to settle, every choice of lifestyle, every environment maintained long enough becomes a new context for biology to respond. The plateau is only one example, but it shows clearly that human evolution is no longer a linear story. It is a network where culture, environment, and ancient traces continually layer over one another. And from that network, humans keep moving forward, carrying not only the body, but the entire history of adaptation, written across hundreds of thousands of years. That is the foundation for stepping into the next chapter, when the question is no longer, how did humans adapt? But what happens when the speed of change in the world outpaces every familiar rhythm of evolution? Throughout human history, countless technologies have appeared one after another, reshaping the way we live. The wheel made movement and exchange possible on a vast scale. Agriculture created stable food supplies and gave rise to villages and cities. Metal brought durable tools, weapons, and new systems of power. Writing allowed memory to move beyond the limits of individual minds, turning experience into history. But all of those technologies, however important, arrived after something far deeper. Long before humans built cities, before they knew how to plant crops or domesticate animals, even before they fully carried the form and mind we call modern humans, a technology entered human life. It was not invented in a single moment. It was not tied to one person or a small group. There is no date or name to remember. It arrived quietly in dark nights and cold winds, in fear of predators and the long stretch of darkness. It was dangerous because one small mistake could burn a shelter, destroy a food source, and threaten an entire community. But when it was kept, when it was controlled, when it became a stable part of daily life, it changed everything. It was fire. Fire is not only a natural phenomenon that humans domesticated, it is the first moment humans deliberately change the conditions of their existence instead of waiting for the body to evolve in order to adapt. With fire, humans were no longer completely bound to the day-night cycle, to ambient temperature, to raw food like every other species. They created light in darkness, warmth in cold, and a center of life around which social life began to form. Fire, therefore, is not only the oldest technology, it is the first marker where culture stepped ahead of biology and opened the road humanity would continue to walk for the rest of history. Fire was not an invention in the usual sense. Humans did not create fire from nothing. They did not invent it the way they made stone tools or spears. Fire existed on Earth long before humans appeared. It flared up when lightning tore the sky. It spread through wildfires that lasted for weeks, It poured from the mouths of volcanoes where rock and gas met in chaos. For most of that time, fire was simply a natural force, terrifying, unpredictable, and completely beyond control. Early humans were not the first to see fire. They were not the first to feel its heat and destruction. What made humans different was not that they knew fire existed, but that they did not run from it forever. The difference is this: humans learned to keep fire. To keep fire means not letting it go out, not letting a brief flare in the night vanish with wind or rain, not letting that precious heat depend entirely on random events in nature. This required constant attention, watching, protecting, remembering. A fire that is kept is not the result of physical strength, but of patience and learning. And here fire moved beyond the role of a natural phenomenon and became part of human life. Keeping fire was not only a practical skill, it was a deep evolutionary turning point. Because from that moment, humans no longer lived entirely inside the conditions nature imposed. They began to carry a piece of the environment, light, heat, and a measure of safety with them. When humans first controlled fire, they did not simply add one more tool to an already limited survival kit. They changed the structure of life. Night was no longer a time left empty and filled with fear. It became living space, a time when humans could gather, observe, and be with one another. Cold was no longer an absolute border that prevented movement. Regions once too harsh began to become livable, not because the human body changed, but because fire traveled with them. Food was no longer limited to what the body could chew and digest in raw form. Cooking opened a new relationship between humans and energy. In that way, fire did not only change the outside world, it quietly restructured how humans lived, ate, rested, and connected. That is why, in hindsight, keeping fire was not simply a successful survival technique. It was the first moment humans stepped outside the rhythm of purely biological evolution and began to write their history through behavior, through learning, and through culture. Fire lengthened the day. Night was no longer a dangerous void that forced humans to curl inward and wait. Light allowed them to stay awake longer, to observe, to prepare to connect. Fire brought warmth, not only to resist cold, but to expand the range of places where humans could live. Regions once too cold became survivable. Humans did not have to wait for thicker fur. They carried fire. But the deepest influence of fire was not light or warmth. It was food. When humans began to cook, they changed the relationship between the body and energy. Cooked food is easier to digest. It costs less energy to process. More calories are absorbed from the same amount of food. That sounds small, but on long-time scales it becomes enormous. A body that spends less energy on digestion can allocate energy elsewhere, to movement, to reproduction, to the brain. Fire, in that sense, did not only change meals, it changed physiology. Not by forcing genes to shift overnight, but by creating a new eating environment, an environment in which certain biological traits became more beneficial. Once again, culture opened the way biology followed. Fire also changed how humans lived together. Keeping fire was not the work of one person. It demanded guarding, protection, shared responsibility. A fire cannot be carried far easily. It bound people together. It created gathering points, shared spaces. Around fire, humans did not only eat. They told stories. They passed on experience. They taught one another things that cannot be learned simply by watching nature. Fire, therefore, was not only a material technology, it was a social technology. It created a new rhythm of life, hunting by day, resting, repairing, sharing by night. A day was no longer measured only by sunlight, but by the ability to sustain fire. And that has a deep consequence. When humans depended on fire, they depended on social learning. An individual could not by themselves reinvent the entire skill of keeping fire. It had to be passed on, protected, as knowledge shared, as experience. Fire became collective knowledge, not stored in genes, not stored in bodies, but stored in community. And like all collective knowledge, it could be lost. Archaeological history suggests there were periods when humans lost the ability to control fire for a time, not because fire vanished, but because the chain of transmission broke. That shows something important. Fire was not a straight, guaranteed step forward. It was not achieved once and never lost. It depended on culture, on social organization, on the ability to preserve knowledge across generations. And when fire was held steadily, its influence spread further. Humans began to reshape landscapes with fire-burning forests to make hunting easier, creating new grasslands, controlling ecosystems in rough, early ways. These were early environmental interventions before agriculture. Humans did not only live inside nature, they began to shape it. But fire also carried risk. It could spread, escape control, destroy livelihoods. That forced humans to learn balance, not only how to use fire, but how to restrain it. This is a crucial cultural lesson. A powerful technology does not require skill alone. It requires social norms. Who is allowed to keep fire? Who is responsible when something goes wrong? When burning is appropriate? When it is not? In this way, fire laid the foundation for a relationship between technology and ethics, long before humans had words for those ideas. In evolutionary terms, fire blurred a boundary that once felt clear, the boundary between body and environment. Before fire, the human body had to face every pressure from nature directly. Cold demanded thicker skin, thicker fur. Raw food demanded stronger jaws, a tougher digestive system. Darkness demanded sharper senses to detect danger. But when fire entered daily life, humans did not have to wait for those slow biological changes. They did not need to become more cold resistant. They carried fire, a source of heat that could be summoned wherever they stopped. They did not need stronger jaws or longer guts to handle tough foods. They cooked softening, making safer, releasing energy before food entered the body. They did not need superior night senses. They created light, pushing back darkness, revealing danger, extending active hours. In all these cases, the body did not change quickly. No instant mutation, no sudden biological redesign. But living conditions changed fast. Within 1 or 2 generations, humans could live warmer, eat more digestibly, and function longer each day. That change did not immediately carve itself into genes, but it changed the kind of pressure the body faced. Traits that were once life or death could become less critical. Other traits linked to learning, social coordination, and behavioral control began to offer advantage. Fire did not directly change genes. It did not design the human body anew, but by restructuring the living environment, fire rearranged the evolutionary board. In those new conditions, over many generations, some biological traits were reinforced gradually, not because they were absolutely stronger, but because they fit better in a world softened in part by fire. In this way, fire was not only a technology that supported survival, it was the first bridge between slow biological evolution and the rapid ability to change life through behavior and culture. And from that moment, humans no longer evolved only in nature. They evolved inside conditions they themselves created. Those who could not coordinate socially were disadvantaged. Those who could not learn and remember struggled. Fire favored traits linked to cooperation, communication, and behavioral regulation. Once again, technology moved. First, biology followed. Fire, therefore, was not only the oldest technology, it became a template for how humans would use every later technology, not changing the body overnight, but changing the living environment. Not forcing genes to evolve, but creating a new context to which biology would respond over time. From fire, humans learned a foundational lesson. When you cannot wait for biological evolution, change the conditions of existence. And that lesson would be repeated with every other technology in human history. That is why, in hindsight, fire is not only a beginning, it is the frame for the entire path humans have walked and are still walking between culture biology and a world that always changes faster than genes. Do humans still evolve? This question often appears at the end of every story about human origins, like a hanging question mark, suspended between past and present. When we look around the modern world with skyscrapers, satellites, artificial intelligence, and advanced medicine, many people feel that biological evolution has finished its job. That the human body has stabilized, that major changes now belong to technology and society, not to genes. But that feeling, however understandable, hides a reality far more complex. Evolution is not a project with an endpoint. It does not stop simply because a species becomes intelligent, or because the environment that species builds becomes more comfortable. If evolution is understood in the narrow sense as genetic changes unfolding across generations under the influence of natural selection, then the short answer is still yes. Humans are still evolving. It's just that the process no longer takes the loud, easily recognizable shape we associate with familiar diagrams that draw a straight line from ape to human. There is no explosive moment, no obvious leap in form, no single marker we can point to and say evolution happened here. Instead, it happens quietly. Small changes hard to notice within one lifetime silently accumulate across generations. They do not spread evenly. They do not affect the entire species all at once. They appear within particular populations in places where people live under different conditions and face different pressures, different diseases, different diets, different environments, different rhythms of life. Selection pressures today no longer come primarily from predators or long famines. They come from subtler sources, the way the body processes sugar and fat, the ability to resist new infectious diseases, physiological responses to chronic stress, or the way the immune system adapts to dense urban environments. These pressures do not eliminate people quickly. They do not purify populations in the dramatic way we imagine in the wild. But they still exist like gentle forces, continuous and long-term. And under those forces, small genetic differences are still being tested. Some become more advantageous in a new context. Others become less suited. There is no symbolic evolutionary event-only process. Human evolution today does not unfold before our eyes in an easily observable way. But it is still continuing, slow distributed, and tightly bound to the very world humans have built for themselves. What makes this question hard to answer is not that evolution has stopped, but that the world humans live in has changed too deeply compared to any evolutionary environment in the past. For most of human history, selection pressures came from direct, obvious threats: predators' hunger and cold lack of water, harsh climate. These were immediate pressures. Fail to adapt, die. The modern world is different, very different. Today's pressures rarely take the shape of a sudden attack. They do not arrive abruptly. They accumulate slowly. They come from lifestyle-linked diseases, illnesses that do not kill quickly, but wear the body down over time. From pollution in air, water, and food agents that are hard to perceive, yet deeply influential. From diets overflowing with energy while the body still carries a biological legacy designed for scarcity. From disrupted daily rhythms, sleep deprivation, extended work hours, a broken day-night balance. And from chronic stress, a state the ancestral body was never meant to endure for so long. In that context, natural selection does not disappear. It changes form. Instead of removing people quickly, it works quietly through its effects on long-term health, reproductive outcomes, and quality of life across decades. And because the pressures have changed, the traits favored by selection also change. It is no longer speed or brute strength. It is the ability to regulate blood sugar, to process fats, to withstand chronic inflammation. to maintain an immune system capable of adapting to crowded, fluctuating environments. These changes do not occur evenly across all humanity. They appear locally in populations shaped by different diets, different environments, and different cultural histories. Some populations show shifts related to how the body handles sugar and fat. Small differences like these can affect disease risk or the ability to sustain health under modern conditions. Other populations show subtle changes in reproductive physiology timing of puberty fertility patterns or bodily responses to signals in urban environments. None of these shifts create a new human species. They are not large enough to split the species apart, but they are large enough to remind us of an important truth. Biology is still listening, and it is still responding slowly, unevenly, but continuously to the living context modern humans create for themselves. However, one thing has fundamentally changed compared to the deep past. Biological evolution is no longer the main guiding force shaping human life. It still exists, but it is wrapped inside a thick layer of culture, technology, and social organization. These layers can weaken, redirect, or even temporarily neutralize some classic selection pressures. A person with a severe genetic disorder may live longer and have children thanks to modern medicine. Individuals who would not survive harsh natural conditions can still exist and contribute within artificial environments. That does not erase evolution. It changes the rules of the game. And the new rules raise a deeper question, one that no longer fits entirely inside biology. If genes no longer directly determine who lives, who dies, who reproduces, and who does not, then what is truly evolving in humans? The answer does not lie in any single body. It lies where we have been tracing the whole journey, behavior, knowledge, and the systems humans build. In the modern world, the fastest changing things are not body shape or genetic structure. They are how humans think, how they organize life, and how they solve problems. Ideas are born, tested in reality, copied, transmitted, modified, or discarded when they no longer work. This process resembles evolution in a profound way, yet it does not occur in DNA. It occurs in social networks. A good idea can spread across millions of people in just a few years. An effective organizational model can be adopted across continents within a single generation. No biological mutation can spread that quickly, but it would be a serious mistake to assume that because culture evolves fast, biology becomes irrelevant. The two processes are not separate, they interlock. Culture moves first, creating new contexts. Biology does not vanish, it responds slowly. When technology changes diet, the body does not change overnight. But across generations, the way the body processes energy may shift. When urbanization changes daily rhythms, artificial light, extended work, fragmented sleep, the nervous system and endocrine system must operate under new conditions. These pressures are not strong enough to create dramatic, immediate biological changes, but they are continuous enough to leave traces. Every cultural change, whether in how we eat, work, communicate, or organize society, creates a new field of biological pressure. Some pressures are very light. Some affect only part of the population. Some are blurred by medicine and technology, but they still exist. And inside that interlocking space, human evolution today is no longer a linear story. It is an ongoing dialogue between what humans invent and what the human body can endure and adapt to. Ideas go first. Bodies follow, not hurried, not certain, but constantly responding. This is the most distinctive form of modern human evolution, not rapid genetic transformation, but continuous resonance between a speeding culture and a quietly adjusting biology, trying not to be left behind. Perhaps the biggest difference between the present and the past is not whether humans still evolve, but our awareness of evolution. For the first time in history, a species understands that it is evolving and may even intervene in that process. We edit genes in laboratories, make reproductive choices based on tests extend lifespan with biomedical technology. This does not make evolution stop. It makes evolution reflective, beginning to be shaped by intentional decisions. That reflection carries responsibility. When natural selection operates blindly, it has no ethics. But when humans intervene, every choice carries social consequences. What do we favor: health, intelligence, psychological adaptability, or diversity? There is no purely biological answer to these questions, because they are no longer only questions of nature, they are questions of values. In that context, the question, do humans still evolve, should be read differently. Not as curiosity about a distant future, but as a reminder about the present evolution is unfolding inside everyday choices. How we eat, learn, work, build society, and treat the environment. Those choices do not immediately write themselves into DNA, but they determine the context to which DNA will respond across future generations. Look wider, and human evolution today becomes the evolution of the human-made ecosystem. Cities' information networks, global supply chains, and a shifting climate together, they form a new environment where biology and culture coexist. In that environment, the most important adaptive capacity is not only physical endurance, but the ability to learn throughout life, adjust behavior, and cooperate at large scales. This brings us back to a central idea running through the entire journey. Humans persist not because we evolve faster biologically, but because we adapt faster through how we live. When genes are slow, behavior goes first. When biology hesitates, culture opens the way. And when the two meet, human history bends into a different direction. So do humans still evolve? Yes, but not in the way we usually imagine. Evolution is no longer a story of obvious morphological transformations. It is a story of subtle, distributed adjustments shaped powerfully by the systems humans themselves construct. It continues in the background like a slow current, while the surface of life is shaped by the breathtaking speed of culture and technology. Perhaps the more important question is not whether evolution continues, but what kinds of pressures we are creating for the future. Because evolution, no matter how slow, always responds. And those responses, good or bad, will not belong only to biology. They will leave marks on how humans live together on this planet. When the final chapter closes, what remains is not a firm conclusion, but a quiet recognition humans have never stood outside evolution. We have only changed how evolution touches us. And in a world that changes faster than genes, the greatest human responsibility is not to become more evolved, but to live wisely enough that the changes we create do not exceed our own capacity to adapt. And as this journey comes to an end, perhaps what lingers isn't a stunning discovery, not a special gene, not a dramatic evolutionary moment, but a very quiet truth that, for most of our history, humans have not lived in a state of safety. We have lived in a state of not yet collapsing. Each generation has stood on a thin line between existence and disappearance, between adaptation and extinction. And to cross that line, humans did not wait for the body to change in time. We changed the way we lived, changed the way we ate, changed the way we stayed together, changed the way we remembered, changed the way we passed experience on. Those things leave no obvious fossils. They do not imprint themselves into bone, but they are preserved in another kind of memory, collective memory. That is why human history is not only found in museums, but also in the way we put on clothes when it's cold, the way we cook our food, the way we build homes, and the way we teach our children. Things we ourselves never had to discover firsthand. If there is one thing this video hopes to leave behind, perhaps it is a gentle reminder. Biological evolution teaches us patience, but adaptation teaches us responsibility. Responsibility for the environments we create, responsibility for the knowledge we pass on, and responsibility for the choices that the next generation will have to live with. If you've listened this far, thank you for taking the time to slow down. Tell me, where are you listening from, and what time is it for you right now, and please follow our channel. Wishing you a quiet night. And if sleep comes, let it come naturally, the way humans have always endured, not by rushing but by adapting quietly. Good night, and I'll see you again tomorrow.